In the second part of lesson 4, we're going to look at an alpha beta test, A/B testing, or alpha beta testing. Alpha beta testing is used by companies to figure out if some change in policy or website design or maybe an office is increasing traffic or increasing sales. So this company redesigned its website to increase its conversion rate. The conversion rate is the ratio of the number of purchases made divided by the number of visits to a website. So companies obviously want a high conversion rate. They want high traffic, but they also want high conversion rate. Use a table at the bottom of this problem to test this goal at the 1% level of significance. We're going to copy the data in this table to Excel. I'm going to grab everything in the table, and then I'm going to grab something outside the table, paste it right here as match destination formatting. I pasted it in the worksheet L2 in the file name lesson_unit4 SNAR. So I'm going to abbreviate this new, and I'm going to abbreviate this old. And then I'll change this to I'm going to copy this table. I guess we call this the new and this the old. And then I need these statistics. Use match destination formatting. I'm going to change it to proportions. I'll change this to difference. One way to count the number of purchases is to type equal count if. And then I'm going to type new. I'm going to get an error, so don't worry about it. And I'm going to type quote, yes, close quote, close parenthesis. Now I'm going to get an error because I haven't defined new yet. Let's highlight these no's and yeses. We'll name that set new. And we'll highlight these no's and yeses and we'll name them old. Okay, notice what happens when I click on this now. New is now defined. And new website is this blue box here, right? It's kind of everything in the blue box. I'm going to drag this over to here. I'm going to change new to old. I'm going to change new to old. Now is counting everything in the old box if yes. I'm going to drag both of these down to here. And I'm going to change the count if to count A. And then I'm going to delete the yes. And I'll do the same thing here. I'm going to change it to count A instead of count if. And I'm going to delete the yes. So this will count yeses and nos in the object named old. Okay, the next thing we do is the proportions. These are the conversion rates. We're going to divide the 98 by the 962 visits. So this is the number of purchases, and this is the number of visits to the website. And it's about 10%, right? And we need, how many decimal places? We need 4 decimal place accuracy. Now, this is the difference in the proportions, right? Notice over here, we have PA minus PB. This is after or new minus before, A/B testing, right? A for after, B for before. So that's proportion of new, and that's proportion of old. So we're going to take the difference in the improved or alpha version of the website minus the unimproved, the before, right? And we get a point estimate of the difference equal to 0.0230. Now the test statistic is the ratio of these two, right? I give you the standard error of the difference. complicated calculation. So I'm going to spare you that. Changing this to red indicates that that was given. You don't have to calculate it, right? It's a given number. The test statistic is the point estimate of the difference divided by the standard error. And in my case, it's 176.43. Okay, so let's go ahead and put the information we know that we've computed into the website. I'm going to pause the video while I do it. All right, welcome back. I entered the information from the spreadsheet into the answer boxes in the problem. Now, before we move on, I want to go through and answer some questions. The underlying statement here is what? These are our choices: university hypothesis, research hypothesis, null hypothesis, alternative hypothesis. Okay, so it says your company redesigned its website to increase its conversion rate. An increased conversion rate would be what? PA would be greater than PB. Another way to write that is we could subtract PB from both sides, right? And still have the same thing. This and this are equivalent. An example would be if PA were 10 and PB were 8, 10 is greater than 8. The left side would be 2 and the right side would be 0. So 10 is greater than 8. That's equivalent to saying 2 is greater than 0. Okay, so this is an increase in the conversion rate. This is equivalent to saying an increase in the conversion rate. This is a difference in those conversion rates, and that difference is greater than 0. So this is saying it's positive. So this right here is equivalent to that, which shows up in which hypothesis? It shows up right here, right? We got to make that 0. The hypothesized difference is 0 in both cases, right? So this is the alternative hypothesis, right? That's the alternative hypothesis. So this underlying statement is the alternative hypothesis. And this right here is the null hypothesis. Now, if you look right here to the alternative hypothesis, the inequality symbol's pointing to the right. It's pointing to the upper tail of the distribution, right? So this is saying right here, this is an upper tail test. Now, what we need to do is we need to calculate the p-value. We use the test statistic to get the p-value. We can use the normal distribution as an approximation of the binomial distribution if this number is greater than or equal to 5, this number is greater than or equal to 5, or these are the number of yeses, right? The number of no's are the difference between these two and the difference in these two. The number of no's is much greater than 5 for both cases. The number of yeses are bigger than 5 in both cases. So we can use a standard normal distribution to approximate binomial here. So we're going to open up statdistributions.com, the normal distribution, right? This is an upper tail test. So we want the area to the right of the test statistic. So this says use the area to the right of the test statistic, the right tail, right? So I'm going to put the test statistic right here. So according to statdistributions.com, the p-value, this is the test statistic. This is the p-value of the test, 0.039. We want to use 4 decimal accuracy. We only have 3 decimal accuracy. So what we want to do here is we want to calculate the probability of being greater than this value because it's an upper tail test, right? So what I'm going to do here is I'm going to use norm.s. In this case, dist, because I'm going to feed it a number on the number line. And the number on the number line I'm going to feed it is that value. And then I type 1 for true. So I'm feeding this function a number on the number line to give me an area under the distribution. Now, that p-value is 0.9612. This is the left tail probability. We want the right tail probability. So up here in statdistributions.com, what we've computed here is the left tail probability. See that? 0.961. To 4 decimals, it's 0.9612. So to convert this to a right tail probability, I can subtract this from 1. Why do that, right? Why do that? I can just click on right tail. In Excel, I got to subtract it from 1, right? So I'm going to type 1 minus. Typing 1 minus norm.s.dist switches it from a left-tailed probability to a right-tailed probability. And we get 0.0388. Now, to 2 decimal places, the two agree, right? So this is what we want to use in MyOpenMath, 4 decimal place accuracy. Now, at 1% level of significance, so my alpha here, okay, these two go together. These are paired together, and these are paired together, right? This is the probability of being greater than that number. This is the probability of being greater than that number. Here we use .dist because you know the number on the number line. Here you know the area under the curve, and you have to get the number on the number line. So we don't want to use norm.s.dist. We want to use norm.s.inverse. And we feed it an area under the curve known as a probability. Now, this number is negative. Let's go to statdistributions.com. Okay, we know it's an upper tail test. So this 1% is the area here, right? So we're going to change this to 1%, our significance level. It says P equal, right? But it's our alpha level, right? It's the area in the tail, right? So this right here is 1%. The critical value is positive. Why? Because the probability of being less than this number is 99%, right? And so the critical value has got to be positive. So all we have to do here is we have to make it positive. And the easiest way to make it positive is just 2 negatives make a positive, right? So the critical value is 2.3263. Notice that the conversion rate of the improved website is greater than the previous website. This difference in these two, the difference, which is the point estimate of the difference, the point estimate of the difference, the probability of it being equal to 0 is 0. Why? The proportion purchased on the improved website could be less or more than the proportion of purchases on the old website. There's going to be a difference. But what we want to know is that difference significant? And our significance level is 1%. So let's go to our distribution here. Our significance level is here. We want to know if the conversion rate of the new improved website is bigger than the conversion rate of the old website. Another way of saying that is we want to know if the difference in those conversion rates is positive. What we want to know is not only is that difference positive, we want to know if the conversion rate of the new website is significantly more than the old website. If that is true, we expect the test statistic to be greater than the critical value. Is that the case? The test statistic, in my case, is not greater than the critical value. It would have to be 2.4, 2.5, 3, 8, 9, 5. It's 1.7643. It's right about here. It's under the white area of the distribution. It's not under the purple area of the distribution, which is our significance level. So the difference is not significant. The difference is insignificant. The new version of the website increased the conversion rate by how many percentage points? I got to multiply that by 100 to answer this question, right? So 100 times 0.0230 is 2.30 percentage points. Increase the conversion rate by 2.3 percentage points. Since the null hypothesis is what? Rejected, not rejected. The test statistic says that difference is insignificant because it's under the white area. And if you notice, the null hypothesis says the difference is less than or equal to 0. Well, the less than or equal to refers to two areas under the distribution: the area in the hump and this lower tail. If the test statistic were in the hump, the difference is insignificant. If the test statistic is down here, say minus 3.5, then that difference is significant but negative. Test statistic is here or somewhere in here, that would support the null hypothesis. If the test statistic is greater than this critical value, we have support for the alternative hypothesis. That is not the case for my problem. In my problem, I have evidence in support of the null hypothesis. In my case, the null hypothesis was not rejected. This difference in conversion rate is thus, it is positive, but it's positive and significant. When the evidence supports the null hypothesis, our conclusion is what? We cannot conclude that the alternative hypothesis holds. In this case, we cannot conclude that the conversion rate improved. So although the new website increases conversion rate, that increase is not significant. So we may want to go back and tweak the website more to get a significant increase in conversion rate.